Hello, everyone, and welcome to the Cardano Virtual Summit, University of Wyoming edition. My name is Jerry Fragiscatos, and I am Chief Commercial Officer at IOHK. I hope you've had the chance to catch all the great panels during the summit. Once again, we are very excited about the future of Cardano and IOHK and look forward to giving the world access to the capabilities that Cardano offers us as a next-generation blockchain platform. We will now be talking to you about the IOHK partnership with the University of Wyoming's Advanced Blockchain Research and Development Lab. IOHK believed in so much in this lab that we donated $500,000 in ADA to support the development of blockchain technology. It is worth noting that the donation is the largest cryptocurrency gift to the University of Wyoming and among the largest cryptocurrency gifts in general to a public university. Today, you will hear from our distinguished panel, Professor James Caldwell, Professor Mike Brofchek, co-directors of the lab, along with Professor of Practice Philip Schlump, who also happens to be CTO of BeefChain. And if you had the chance to see the BeefChain session, you would have heard from Philip already. I hope you enjoy the presentation, and without further delay, I will pass things over to James. Over to you, James.
Hello, everyone. Greetings from Wyoming. I just thought we would push through a little bit. I'm James Caldwell. The Wyoming Advanced Blockchain Lab. We're calling WABL, and so it's IOHK WABL. I'm the co-director with Mike Brofchek. I'm a professor of computer science at the University of Wyoming, and I have a long background in theorem proving and system verification, verifying fault-tolerant distributed systems. While I worked at NASA, I have a background in VLSI CAD verification, and my research really is in theorem proving formal methods for programming languages, especially functional programming. Mike, do you want to?
So, hello everyone. I'm Mike Brofchek. I am an assistant professor of computer science at the University of Wyoming with joint appointments at Idaho National Labs and a fellow at the Center for Advanced Energy Studies. I was a former hardware security architect at Intel and a data scientist at several startups that then got acquired. My funding is varied across several different sources, but really my research interests are in information theory-based approaches to security, specifically hardware security in low-power, resource-constrained environments, and also developing security metrics for machine learning models that are getting implemented throughout our larger ecosystem. And with that, I will pass it over to Philip.
Hi there, and I'm Philip Schlump. I'm a professor of practice at the University of Wyoming. I teach blockchain and also some advanced database stuff, and my background is a little bit different. I've been working in business for 30 plus years, and I've worked on all sorts of different projects and a lot of hardware projects. So I've been working at this from my area is really the work that we've started with working on some hardware stuff from the bottom up. And I'm very excited about the various different pieces that we can put together on this. This is a very exciting project. So Mike, you want to take it from there?
I was going to hand it over to Jim, but I'll talk really at a high level that we are looking at a collaboration here between IOHK and the University of Wyoming. IOHK is clearly one of the forefront leaders in the blockchain space, right? From a research perspective, from developing open source technology and tools, basically being open with how they develop technologies for the future of blockchain and distributed systems in general. And they have a massively rich technology portfolio that they're looking to expand. From the University of Wyoming, we are clearly focused on education and research, With the particular interest in blockchain, in security, in functional programming, which is key to a lot of the underlying technologies in blockchain, we focus on theorem proving and formal methods, which are going to be critical in developing secure hardware that is provably secure. And finally, we are really looking to enhance the future pipeline, the workforce that is going to be using blockchain technologies from here on out. Jim?
Sure. I guess maybe, this is the result of actually a long path here, the partnership between IOHK and the University of Wyoming. Years ago, about 4 years ago, Caitlin Long made a first trip to Wyoming, and we started with her the Wyoming Blockchain Coalition. And at the time, there was a group in the legislature led by Kyler Lindholm and Chris Rothfuss and others that was really pushing to make Wyoming a special place with regards to blockchain regulation. And I started going to those early task force meetings around the state. They had them about once a month or once every 2 months around the state, and presenting and talking about what UW was doing. We were already teaching some blockchain courses, and we were pretty focused on pushing research in the direction of blockchain at that time. And as a result, the legislature allocated $1 million of funds that had to be matched 1-for-1 externally, and then 2/3 from within UW. So the $500,000 donation in ADA that we took from IOHK is matched by legislative funds of another $500,000, and then UW is chipping in an additional $300,000. So the lab is supported very richly with $1.3 million for the first year and a half. The text on the bottom of the slide there is sort of what comes from the statement of work that we wrote between UW and IOHK. And the main thing is that we're going to specialize in tactical and agile applications of formal methods and testing to verify that hardware and software reference implementations satisfy their specifications. And the goal for the lab is to provide a bridge from theory to implementations. So that's kind of the big picture view of what we intend to be doing in the lab. I mentioned the favorable regulations. I think I heard Tyler say yesterday in one session that 23 laws have been passed in Wyoming. I guess the most exciting one is this one for special depository institutions. But Wyoming has developed an environment that is favorable for blockchain companies to move here. And indeed, IOHK reincorporated in Wyoming. They were originally incorporated in Hong Kong. And so, we're kind of hoping that this is going to, snowball with lots more companies interested in the blockchain community technology moving to Wyoming. And so part of our role in this is educating qualified people with expertise in secure distributed systems, functional programming, and formal methods. I might say that I've been at the University of Wyoming for over 20 years, and one of the reasons I came was that they had a long history of interest in both formal methods and functional programming, which was my own area. And I arrived and they gave me the functional programming course to teach. And that course, I've taught it mostly for 20 years, has been taught in Haskell for about the last 15, and Scheme before that is actually a required course in our undergraduate education program, which is perhaps not uncommon in the UK. I don't think it's that common there or in Europe, but we are certainly unique, I think, among any university in the Rocky Mountain region of the U.S. I mean, CMU and a few others start with some functional programming classes, but we're kind of unique in that way, and our students learn Haskell. So we felt like the combination of formal methods, and I think this is what's convinced Charles that this was really a really good move for him, was to invest in the University of Wyoming, because we have this history of formal methods of research and functional programming, and our students learn even it's an ABET accredited program, but our undergraduate students are as well trained or better trained than most students coming from anywhere. Let's see. Okay, it's a great match to diversify academic research and the development approach taken by IOHK. And I think you can see that throughout this summit, because the amount of deep computer science that has been presented here by IOHK researchers is just fantastic. There's nothing, like it anywhere else in the world that I know of, where you have academic researchers pushing the edge on blockchain systems and blockchain programming and smart contract languages. It's a perfect it's a perfect problem space for us to train graduate students in these areas to get masters and PhDs. So back when I went to the legislature, they asked me at one point to write a proposal about what could be done at the University of Wyoming to build a sustainable, the way it was put to me, we want to see a sustainable research and education program in blockchain. So this is from legislators, and to me, as I was then the head of the computer science department. And my idea was to, focus on blockchain on the research side as much as possible and try to do more hiring in that area, but also to establish a kind of a interdisciplinary center at the university. And I think that Steve Lupian talked about this a little bit yesterday, but the idea, and thank goodness, the College of Business have kind of taken the lead on that in terms of having a center of excellence, which is an umbrella over other programs in different colleges. And of course, the IOHK Blockchain Lab at Wyoming will be under that umbrella. And so we're kind of the research arm, but there's going to be business and finance and law included under that program. There'll be a minor, a certificate program that students in all disciplines could take so that they are trained in kind of the basics of blockchain technology to be able to identify use cases in their jobs as they go out into the world. The minor will be a minor which is joint between the College of Business and computer science. And then in computer science, our bachelor's, masters, and PhDs all focus on blockchain. We're hoping to, our goal, the ideal graduate is a student who is positioned to define and solve the next generation challenges in the space. So we're focused on formal verification, smart contracts. We've been working on Marlowe, looking at Marlowe and doing some work in the Marlowe area and secure hardware. I think we've got some slides here that talk together about those individual projects. So the first focus, so there's kind of two, there's the software side and then there's the hardware side. So I've mentioned functional programming and how all of our undergraduates take it and many of our graduate students use it in their work. That we teach formal verification and proofs of programs running on the blockchain, and that, we're looking at Plutus and domain-specific languages. So let's look at what we're doing on the Marlowe side. I should say also maybe that we've put together very quickly, I think, a really great team. We have 2 PhD students and 3 master students and an undergraduate researcher working with us. And the funding from IOHK through various, bureaucratic issues at UW did not actually arrive for us until mid-June. So we've already done, I think, a fair amount of interesting work. When you look at the smart contract side, Philip taught Marlowe in his blockchain course in the spring, and we started looking at Marlowe and looking at the code that's out there on the Git repository, and realized that a lot of the use of, so Marlowe is embedded in Haskell, so it's a domain-specific language that's embedded in Haskell. And so what you do to write a Marlowe program is you essentially type in the abstract syntax for Marlowe into Haskell, and that's a data type in Haskell. And then you can use Haskell for other things, surrounding the Marlowe code. So the main thing that we noticed that Haskell was being used for was abstractions, defining abstractions. You want to be able to define a function that returns a contract, for example, or you want to define a function that returns a value. And so we're looking at we've implemented parameterized abstractions for contracts and values at this point. And so it's a kind of a let construct. It doesn't break in any way the pure functional nature of Marlowe. And we've integrated it so that it's actually just a very simple add-on of 2 constructs in the Marlowe language. And then we have extended the evaluator to include that. And it looks like a very interesting extension. We've met with the Marlowe team and we've gone over what we're doing, and we have a Slack channel. We're all working together on pushing Marlowe a little bit. So I think it's an open question as to whether it would be a good idea to build a standalone version of Marlowe to kind of lower the cost of entry into writing Marlowe contracts. Right now, you have to learn at least a kind of a very basic, anyway. You have to learn Haskell in a basic way. But it looks to us like it's not perhaps that difficult to extend Marlowe a bit more to make it a standalone smart contract language. We've also got students who are following the Plutus development extremely closely, watching the Git updates. And we're looking at zero-knowledge applications in Plutus and building a Plutus backend or designing, because Plutus is we still don't have the latest version, it's still under development, but the backend for Ledger, for the Go Ledger spreadsheet. So Mike, I think the next one is about hardware. Would you like to talk about hardware?
Sure. So we've actually broken up our hardware challenge focus into 2 different approaches. We are interested both in a top-down and bottom-up approach to creating secure hardware. So from the top down, you have a specification of a secure cryptographic process, whatever that might be, and your goal is to get that into some hardware. The questions you should ask yourself are, is it still secure after it's in hardware? And there are many different reasons why that might no longer be the case. And so what we're really looking for is a repeatable process to do automated, secure development of these circuits. So if you've watched some of Charles's videos, he actually goes through and details kind of the use cases for why you want secure hardware and how it would interact with a blockchain. So one of our first steps is actually to take, what's currently existing. So I'm not going to give away all the secrets here, but there are already some cards, and you probably have one in your wallet that has a cryptographic processor inside, pretty lightweight. The question that you have to ask yourself is, can I extract, well, one, the cryptographic processor from the actual chip? And yes, that can be done. And two, how much information is that leaking? So one of our things that we're doing in our lab is actually looking at how much side information is leaking from common cryptographic processors so that we can actually then test our methods to make sure that they're secure. So we're basically building a full pipeline from high-level specification all the way through implementation of a protocol, and then implementation into hardware, and then having a repeatable test bench to basically say what we've developed is actually secure or it has some vulnerabilities. So in a nutshell, we are looking to secure hardware from the top down, and I'm going to pass it over to Philip to talk about how we're doing it from the bottom up as well.
Yeah, from the bottom up, one of those questions that always comes up is if we want to do something like what Charles talked about, building a NFC chip that has signatures, what are the bounding conditions that we've got to work in? Because if you look at a practical point of view, I've been involved in a lot of projects and a lot of years of consulting work. The thing that made projects fail was they didn't have a proof of concept to start off with. So I want to put a box around, this is the things we can actually build. This is the things that we can do. And when we first started looking at NFC chips and how their protocols worked, we went, well, we're going to do this over here. And as soon as I actually went out and tried it, I found out, no, that's not going to work. That's not really the way they work. So we started a little side project from the bottom up to build an emulator that implements a ECDSA signature in an emulated NFC chip so that we can test out what protocols can we actually use, how do they work, which things can we actually do, and figure out just some basic parameters of how much power do we have to work with, how long do we have to work with, what is the communication, so we can get a physical, limits on if we're ever going to actually build an NFC chip that does this, it has to fit inside these engineering constraints. And so far, we have gotten to the point where we have a partially humanly implemented scan system that works within a NFC protocol that already exists. So we're making progress in the low-level hardware of how do you get to talk to an NFC chip and how do you validate signatures down at the grunge level in the NFC protocol, which things are possible given the existing software and hardware. Most people don't realize, but virtually every smartphone can read and write NFC chips and can emulate an NFC chip today. So our potential application we're building is to have one smartphone act as an emulator and the other one act as a verifier for this emulated NFC chip. So that's kind of the low level. The other thing I would mention is somebody asked about the our Center of Excellence and what are the things it's doing. We're actually working on an accounting system that will use the tokens inside Cardano to track accounting and verify that the accounting is not, that things have not gone astray in the accounting and fraud has not occurred. So that is certainly on the other side of this, which is a practical application out in the land of accounting. And Jim, did you want to take it from here?
Oh, I guess that's the end of our slides. We are, I think, probably in a similar situation to most other universities, if you read the papers at all. it's a kind of a dilemma of what to do in the fall. UW is planning on having kind of limited in-person classes in the fall, which is, quite a few, Cornell's doing it, quite a few different universities are doing it essentially the same way. We'll see how well it works. But because of that kind of uncertainty for the future for the university, we're in an exceptionally good position to be able to hire in this area with both graduate students and postdocs, and we, are also looking for visiting professors. So if if any of these projects sound interesting, or if you have other ideas on Cardano-based work that you think would be interesting to perform in this IOHK-funded lab, please send us an email. We'd be very happy to hear from you.
And also complete a form on our website at uwyo.edu/IOHK and just pop us a message that way if you don't want to start an email chain.
So Jerry, how are we doing on time? Did we run over? We're way under? I don't even know.
We got plenty of time. We might as well just go into an open discussion while we wait for some more questions to come in. One thing I find very, very interesting is the difference between software research and hardware research, right? These are fundamentally different areas of pursuit. And I'd love, and I know it's early on, but I'd love to hear, either Mike or James or Phil, or maybe all three of you, your take on what are the unique challenges between both of them? What are surprising things? Maybe we would expect hardware to be a more difficult area of research just out of the gate, right? Talk to us about that, the different challenges, pros and cons, and also the relative timelines between doing software and hardware research. This is something that fascinates me because when I got into this company, I just assumed we'd be only looking at software. But through our commercial pursuits, we found quite quickly that a hardware component becomes important. And this is kind of where it starts as research, then we go into software development, then we start doing our use cases, we bring it to market, and then we find out that a hardware component is important. So I'd love to hear more about this software and hardware interplay and the differences between those. So, I'll open up to whomever to kick that conversation off.
I might start off just by saying that I worked at GE at the corporate R&D center in Schenectady, New York in the 80s, doing VLSI CAD work and verification work on hardware. So formal methods has been for a very long time an important component in building hardware. I think, after the Intel floating point bug, which is long ago now, but they lost at the time, $750 million because of the bug, suddenly everyone started realizing, if they had done formal verification on this thing, this could have been avoided. And so, in fact, the hardware companies, Intel, AMD, various smaller special, I've worked with Rockwell Collins and Honeywell. They have embraced formal methods and, more than software developers. And partially it's because hardware is complex, extremely complex, but it's more fixed than a distributed program where processes are popping into existence and disappearing, and you have, this kind of more, effervescent behavior. If you kind of try to imagine the behavior of a complex distributed system, as opposed to a piece of hardware, whatever that is on the chip is on the chip. So really, the hardware people have made some of the greatest advances in applying formal methods in there and using them in their regular development area. So I think that's a huge a huge overlap there. And then the other one that I'll quickly mention, then I'll pass it over to Mike because he's more the hardware guy, though, is that pretty much these days, hardware is designed in VHDL or Verilog or essentially using a programming language to describe the hardware. So even hardware, I mean, unless you're doing something like device physics, which, you know, we're not going to be doing, unless you're doing something very low level, unless you're trying to push the next edge of making, you know, devices smaller and smaller, which is not the area that we're looking at. We're looking at how can we build hardware that will implement cryptographic protocols in a useful way. So, Mike, do you want to chime?
Sure. So the biggest issue, and actually Jim has alluded to it already, is actually that when you're developing hardware, that you are dealing with device physics. So I mean, most designers don't care about it because it's somebody else has handled it. Somebody else has done all of this hard work to create essentially your fundamental building blocks, so that you can use a higher level programming language to build these. The problem becomes when you're now implementing something that is known secure. So when you do your software development or your theoretical development of a cryptographic algorithm, you now actually have to deal with the impacts of implementing this process in the real world. I'll give you a real world example that you can actually test out for yourself in terms of how we can start exfiltrating information. So if I ask you to add two numbers together, so let's say that there are two one-digit numbers, you can do that. And on pen and paper, you wouldn't actually be able to detect the size of the numbers that a human was adding, because all you would see is the inputs and the results. You wouldn't have any kind of indication. If I ask you to do it in real time out loud, and I ask you to add two numbers together, and your options are two one-digit numbers or two 100-digit numbers, there's going to be a time difference in how long it takes you to answer. Now imagine that instead of a human doing this, we're talking about some hardware doing this. How much energy does that take? How much time does it take to process that? There's a conversion of a theoretical thing, an algorithm, into reality, into the physical space, and ensuring that now this transformation into the physical world is secure is actually an incredibly hard problem. The verification that it does what you say it does, that is, I mean, as Jim has already said, hardware companies are spending a lot of money to already do formal verification of, you know, is what we built what we expect it to be built? Well, the next phase of that is what we built still secure? Right? So you'll see in the past 2 decades now a huge amount of literature that talks about exfiltrating data from hardware. And it is very challenging. It is hard to do. But basically that is, that time. So Jerry, you asked about the amount of time it takes to develop. Well, it might take a long time to develop a cryptographic algorithm that is provably secure. But actually validating that it works in hardware, going through the whole step of manufacturing, of fabrication, and then testing and analysis, the time cycles just increase drastically, right? You can't throw more people at the problem to make it go faster, right? You are limited by the fact that you at some point have to manufacture this device and test it. So there are some limitations, but basically Jim captured it really well. There's a lot of work that's been done, and we aren't looking to change device physics. That is somebody else's ball game. But we are looking to see what properties are there of these fundamental units. Can we combine them in such a way at a high level, such that when we actually implement it in hardware, that it's still secure?
That's really interesting. One thing that I caught what you just said is the formal methods aspects of the hardware. I have like a two-part question. The first one is, does the fact that you do these independent research, do they cross-pollinate, right? In other words, because you're doing research in the hardware space, that informs the research you do in the software space and vice versa? That's the first question. And the second question, do you believe that there's an opportunity for vertical integration, right? Apple is the classic case where they managed to get a better user experience by integrating hardware and software. So I'd love to hear first the cross-pollination between the two research channels, and secondly, your thoughts about vertical integration.
I will say absolutely yes, that they are related, right? One informs the other both ways. It's not trivial, and it takes time, but that is why we're also taking a bottom-up and a top-down approach to the hardware process. It has to. You can't wait for one before doing the other. Otherwise, you'd never have a product. But they do both inform one another. And the complexity is what works in one hardware technology doesn't necessarily translate to another. As you go to deep submicron technologies in hardware, you start getting different, the device physics changes. So it is actually a very complex problem, but yes, one that where information that is fed back up into the higher level abstraction levels is incredibly useful. For cross-pollination, I think that it does help, right? A more secure stack as a whole is going to lead to better experiences and, from a usability standpoint, and also risk mitigation, right? When both your hardware and software are secure, that has broad-ranging impacts, but I will let Phil and Jim also answer.
The thing that makes Apple special by and large is the fact that they get to provide a fit and finish and a polish on their products that isn't at the level of just the software. It includes the hardware. It includes the ability to make choices. And those choices are critical to the quality of their end product, is how they work together. Because, software by and of itself doesn't run on much. Programs have to have some hardware there. So, combining them together is a critical thing. When you look at this, a large part of the reason why we did this split with the bottom up is that to actually build it into hardware, you end up with limitations. You don't have the choice of doing things. And ultimately, those limitations at the engineering level are the ones that will make decisions happen at other levels in how we go about doing things. And they do cross-pollinate. You find out things at the hardware level that you go, oh, I can actually do X cheaply, when maybe at the software level it doesn't work that way. I worked recently on a microcoding project and found out that this process that I would have thought would be very slow, down in the level of microcode, I can do very, very quickly at a low cost, because there is a way of doing it. So sometimes these things don't just cross-pollinate. They feed back new information and new approaches to the higher levels to say, let's do this other way. Let's save some power and some time, and let's actually build this down in the hardware where we can do it efficiently in some fashion. So part of the question on the hardware is, what choices do we have available that otherwise we might not have if we're just building software? I worked on the validation for the Department of Defense of a Motorola processor for certifying it for going to space. And the software that we used for that is the same software that we're going to be using for validating stuff in Marlow. So, the theorem proving is the same, and they do feed back on each other.
I guess I'll just chime in and say, it goes both ways, the cross-fertilization between the two areas, especially when you're thinking about, verified hardware. There's just a huge amount of cross-fertilization that happens there. I think the hardware people have developed the model checking which is an automated method of proving correctness, has really been pushed on the hardware side, and it has a lot of value on the software side as well.
Thank you. I'm going to do a two-parter, a practical question, and I'll go to a bit more of a theoretical question. On the practical side, as Chief Commercial Officer of IOHK, the one thing I found a pleasure working with Wyoming is this interplay between government, business, and research. And having worked with the team on Beef Jam, I know Phil, you're part of this team. There is this network effect that happens. That's kind of the whole is bigger than the sum of its parts, right? You know, starting off with talking with clients, then the business community, researchers, and so forth. We start getting some feedback about strategy and about, you know, things that you wouldn't necessarily make the connection. And then you've got people that are part of the university that used to be, you know, ex big shots from industry that come in and give a unique perspective. You know, I think this question is more directed at you, Phil, because you do this crossover between the university and the business side. Is maybe you could expand a bit more about that. You know, I'm trying to think of the word here. It's kind of what you get like in Silicon Valley or like in China, where you get all these manufacturing ecosystem together. There seems to be, you know, this extra energy that comes out of combining things together. And I'd love to hear, Phil, your experience about that.
Well, you know, Wyoming is not that big a place, and we all have to play multiple roles here to get things done. And we have a rather unique legislature in that our legislators are not actually paid, they're volunteers. So, you know, there are things like that that you don't run into in other places. Um, it does require cross-pollination. I mean, to look at any of these things in isolation, you know, doesn't ever make sense. And we have legislators that are working to build a more favorable regulatory environment for blockchain and blockchain applications, but that doesn't do any good in isolation unless we actually take advantage of it and push that into real businesses that are going to use it. And the foundation long-term economically of these businesses, and I give IOHK tremendous credit for this, is that you have to have some research. That's the stuff going in at the beginning that allows you to build things in the future that are of value. That's what pushes it forward. So some pieces at the university where we can take expertise and add that back into the business community and allow it to prosper is a critical factor. So combining them all together is it's teamwork. There's no I in teamwork, and it has to have multiple pieces work together. The nice thing about Wyoming is that we do have, you know, a small enough community that we can, you know, get with the regulators and say, we need these things, and they can go, okay. Or, you know, the banking commission. And I literally sat down for a lunch with Alfred, who's the head of the Wyoming Banking Commission, while he said, what do we need to do to improve our security, and how can we improve security for banking in the state? And sit down with the regulators and work with them on, these are the things you need to do. This is what's actually out there and working. And that is a tremendous advantage to getting things built and getting things done. We have a lot of support from the regulators in this state to not just do that, but continue to do that into the future and build on that for the future of the state and for future of companies like IOHK.
I guess I just want to chime in because I, as department head, spent years going to every kind of there's like a broadband summit. There's former Governor Meade started it. It's still going. The Jackson Hole Tech Summit. There's been a long push for a long time now in Wyoming to try to diversify the economy because we are in serious trouble. Oil went to negative $35 a few months ago. Our negative 35. It's unbelievable. So the Wyoming economy largely depends on the export of coal, which is, dare I say it, essentially a dead industry, oil and gas, which are both in probably long-term trouble as well. And so there's been an effort for at least 8 years to try to figure out how do we diversify the economy. And Governor Meade formed a special committee called Endow, which is to essentially diversify the economy. And I would say that it's just kind of been the legislation that has been passed in the Wyoming legislature and signed by the governor on blockchain related stuff has been the first time since I've been here, which is 25 years now, 24 years, the first time where the environment is really ready for, is ripe for companies to move in that are interested in the blockchain area. And I'm saying before, we try to attract other tech companies for quite a long time. So, I've been involved in trying to bring companies to Wyoming, and sometimes it's successful and sometimes it's not. But I think the situation is ripe right now with this, and the collaboration between the government and the university and kind of the private sector is, I think, unique. And the other thing I just want to say is that, at last year's hackathon, it's probably on film somewhere in the archive, the hackathon archive. But there you have the Tyler Lindholm, staunch libertarian Republican, standing with Chris Rothfuss, a Democratic senator from Albany County. They've been working on this thing together in a completely bipartisan way. I don't know that there are any efforts anywhere in the country that are as kind of open to collaboration for the good of the community. So I think it's a very interesting place to be right now, Wyoming.
I got one philosophical question for the industry, and then we'll get to a few of the external questions that have been submitted. And I guess this one probably best lies with Mike, but anybody could feel this one. Is Moore's Law dead?
No. I don't know. That's you're right. It is a philosophical question. Yes, but we are doing advances in advanced hardware technologies. Quantum is on the forefront. It might not look exactly the same, but the idea that we are rapidly and continue to rapidly increase our capabilities with smaller and smaller hardware is not changing. We just find new ways of doing it. So, in its original statement of form, when you're talking about transistor counts, yeah, it's probably gone. With that said, though, I will say that the new issue, right? We are rarely are we trying to fit more and more transistors unless you're looking at doing advanced AI capabilities onto a circuit, onto a chip. What's actually now more interesting is that we are looking at doing ultra low power, and this isn't entirely new, ultra low power, very customized circuits that honestly aren't really exceeding the die area of a processor. The problem with that is what we expect those really small custom chips to do. So you can think of, to frame this, you could think of the huge Internet of Things. Ultra lightweight, not very intelligent devices doing things. They're not really, we've gotten them to be ultra low power, but they're all just sitting out there pretty much open and vulnerable. So, but no, I don't think that the overall Moore's Law is dead. It just has changed from your idea of a traditional transistor to something much, much different than that.
I'll just chime in and say that, Moore's Law is dead in exactly what Mike was saying, but we are putting more processors on chips these days. So what that does is that pushes off the problem onto the software on how to use all the parallelism that is available in chips today. And so, yeah, it's things are still moving faster because we still have we now have more processors. And actually, this is one of maybe the successes of functional programming is that, it makes it easier to do distributed computing when there's a less shared or less mutable state like we have in the functional realm. So there was huge foresight, I think, on IOHK's part to adopt Haskell and to embrace kind of functional programming as the basis for these massively distributed complex systems, because they're the only ones that you really are going to be able to reason about.
So thank you. All right, I'll get to some of the external questions now. We have a question from M. Patel. This feels more like a question for our CTO, our chief scientist, but there's probably some interconnection here. The question is, how could Cardano use something like a hub to connect various networks for each individual to have their own blockchain, which is cryptographically encrypted with each transaction, so users can connect to the Cardano network to verify their transactions? So all this could perhaps decrease the blockchain size. And the other part of that question is, could Cardano smart contracts run on Hydra? If I were to abstract this a little bit, I guess it would be around interoperability between chains, side chains, and Hydra is kind of like these independent channels going side chains and smart contracts associated to them. You probably don't have the answers for these specific questions, and I'll relay them to our chief scientist and our CTO. But I'd love to hear your take about interoperability between chains, side chains, and how the ecosystem of kind of like the multi-chain architecture you think is going to end up looking like, to your best knowledge.
And this is Philip. Hydra provides the ability to actually have an effective side chain that you do heavy computation on. And there's no particular reason why on that Hydra you can't run some heavy computation that is necessarily a different chain and come up with a result that you can then return back to Cardano, to its chain. The interesting thing about this is that really the way you're doing Hydra is the first thing that is explicitly creating the ability to talk to an outside chain with a protocol that's been shown to work and communicate with outside chains. And it's done in a fashion that is scalable, where it could be as many as you want to have. If you look back a couple of years, you'll see other people doing parallel chains where they've said, okay, we're going to implement a parallel chain, and the name of it is escaping me at the moment, but a parallel chain with 64 different parallel chains, but it was always fixed at 64, which is not really a scalable solution, whereas Hydra provides this capability of scaling out and talking to other chains. I don't see a particular reason why you couldn't build a wide variety of smart contracts like Marlowe that are running on a Hydra chain, where the work is being done outside, and then you have the Hydra proof of completion at the end of a particular set of work coming back into the Marlowe chain. I think that's certainly, from my reading of the documentation and looking at how it works, it seems like it would be a straightforward thing to implement that kind of an approach. And that means that the chain or contracts can run outside and turn around and come right back to the main chain. The interesting thing about this is this opens up the possibility of running some really heavy-duty contracts. One of the limitations that you see in Ethereum is you're heavily bounded by the amount of time and the cost of running a particular contract. There's been some good theoretical research out there to say that if you had a small number, about 9, outside implementers running contracts that are chosen in the right kind of a fashion, that these 9 provide the same level of security as, the Ethereum chain with, what is it, almost 12,000 nodes out there. And you have some tremendous benefits in terms of, those 9 can run something, and they can do it in a fashion that isn't impacting the main chain. then they can spend some time and effort working on things. They're not bounded by the same set of constraints of everything has to happen in X number of seconds with, so much gas or less, or it won't work. So Hydra provides some capabilities, and it certainly could be used in this kind of a fashion to build outside contracts.
Thank you for that. I hadn't realized that you had looked over the Hydra paper. That's great. Wonderful. All right, I think we probably have enough time for one more question, and I'd probably ask all three of you to answer this last one. And it's relevant to the university. What is the main challenge for you for attracting talent, first in the industry, but also to Wyoming in your research facilities?
First, the main challenge here is, we are in Laramie, Wyoming, I think. And the good thing about Laramie, Wyoming is it's a little town, and we're 124 miles away from Steamboat. Place.
Oh, I think that's right. I mean, in some way, I think the people who end up coming to Wyoming and staying in Wyoming kind of self-select for themselves, right? Access to outdoor activities is just, phenomenal. Winter sports, summer sports, outdoor hiking, backpacking, rock climbing, mountain climbing, all these things are just, they're here. They're right at your doorstep. River rafting, skiing, I mean, the list is endless on that side. But the people, it's kind of self-selecting. I think people come here and they settle in and they either like it or they don't. And if they don't, they end up, moving on.
So I will echo those sentiments, but I will say that the University of Wyoming is like the startup of companies. It is a place where you can have as much responsibility as you want, and you take it and you run with it. And then if you would thrive in that kind of environment, this is probably the place for you. If you're looking for a place that has 30, 40, 50 other researchers working on the same project, that's not going to happen, right? So you have to take ownership, and that is probably one of our biggest selection mechanisms. You have to want it, you have to want to do it, and you have to be willing to collaborate with others that you might not normally collaborate with. So the idea of cross-functional teams, that there is not one, one giant conglomerate that is focused on task X, where you have to leverage other resources, is really critical, and it's just not for everybody, right? And I think that's one of the other giant pieces of the selection mechanism that people, when they self-select, if they like the outdoors, that's great and all that, but when it comes to the work on a daily basis, you've got to own it. There's no one to throw it over to the fence to somebody else.
I guess I would just say I've lived in New York City. I've lived in Boston, in the heart of the city of I've lived in Manhattan and in Boston and all over the East Coast before I moved here about 25 years ago. It is a difficult thing to explain because if I say to you, there's never a traffic jam in Laramie, you say, what would I say? I would say, oh, yeah, I used to commute in and out of Manhattan. I'd say, oh, well, yeah, it's just part of the life there. But then it's gone. There's never a line at Safeway. I go to pay for these are kind of minor, little, tiny things. But after you live in a town like Laramie where people are friendly and there's never a line, you go to motor vehicles and they want to help you. It's very different. It's very different from, living many other places. And I've lived many other places. And so that kind of level of, I don't know, maybe cortisol or whatever the thing is that builds up with stress. The level of stress just from kind of daily life is less. But, we have wind.
All right. Well, right at the hour, it seems like it's flown by. So thank you very much to the distinguished panelists. Thank you to the viewers. And for those of us in the US, happy 4th of July weekend. Thank you so much for your time.